Hallo, it's Dumplet here. Here's an item on number theory. How many integer pairs x, y satisfy the following? X squared minus y squared is equal to 4x plus 6y plus 106. So this question came from DAM 2022, an examination that Dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. So taking a look at this given, we have technically two squares. So x squared and y squared being equal to 4x plus 6y equals 106. So knowing this is a contest problem, we might try to use factoring here because it is an equation in integers. So possible things we might do is checking parity. Maybe we can do some factoring. Now in this case, we have squared terms, so we could probably use some algebra first to take care of these squares, and maybe something nice would be able to appear, maybe some factoring here. So let's try to put all the variables into one side. So we're going to have x squared minus 4x, and then minus y squared minus 6y, and let's just put the 106 on the right side as you can see here. Now let's try to complete these two squares. We have x squared minus 4x and this minus y squared minus 6y. So for the blue one, so the x squared minus 4x, what I'm going to do is to add 4. Right? That's going to be the first one. And then for the green one, I'm going to factor out the negative sign first. So y squared plus 6y. And I know I have to add 9 here to make this one a perfect square. And then the right side, it's going to be 106. But take a look here. We did a plus 4, so let me put a plus 4 here. And then we technically added 9, but we factored a negative sign out. So that's in effect a minus 9 on the right side here, right? So we have two squares here. So the square of x minus 2 minus the square of y plus 3, and that's going to be equal to 101. So 106 plus 4, that's 110, minus 9 is 101. So far we have this one. And, well, factoring comes into play because we have a difference of two squares. We could just imagine this is like a squared minus b squared. We can do the factoring as follows. So we're going to get here x minus 2 plus y plus 3. So that's going to be the first factor. Then the second one will be x minus 2 technically minus y plus 3, but let us distribute the sign. It's going to be minus y minus 3. So we distribute the sign. That's going to be equal to 101. And that's just going to give us x plus y plus 1 times x minus y minus 5. All right? And that's going to be equal to 101. So essentially we just have this, and we have to solve for integer ordered pairs, x, y. Oh no, sorry, not solve, but to get how many integer pairs are there. So since we have two numbers that multiply to 101, it would be nice to take a look at factors of 101. Now 101 is prime, so the factors, the positive divisors is just 1 and 101. So we could write them as, let's just assign the factors. Let's say the first one can be 1, and the second one can be 101, or we can switch them. And don't forget the negative ones as well, because x and y are integers, so it is possible for these factors to be negative. And let's take a look at things here because, well, we have two factors, x plus y plus 1 and x minus y minus 5. And if we add them, actually, we're going to get 2x minus 4. So the reason why I'm adding them, it's because it eliminates the y. So it kind of helps us answer this question a little bit more smoothly. So the sum of the two factors is 2x minus 4. And we could consider the sum of the factors in each possible case. So for example, in the first case, we know that 2x minus 4 is 102, right? Same in the second case, 2x minus 4 is still 102. And then in the last two cases, 2x minus 4 would both be equal to negative 102, right? We could try to solve for the values of x in each case. So the first two gives us x is equal to 53. And in the second case, it's going to give us x equals negative 49. All right, negative 49. Now we have 4 values of x, so it is expected that we have 4 values of y. Now, it might be obvious to some that y must be an integer, but let's just try to get the values of y so that we are sure. So let's just consider the first factor. Let's just try to just consider x plus y plus 1. Now, in the first case, x is 53. So the green factor becomes y plus 54 then, and that's equal to 1 in the first case. So the first case gives us y equals negative 53. So in the first case, we're going to get x is equal to, we're going to get y equals negative 53. So that's one ordered pair of integers. In the second case, where x is 53, but x plus y plus 1 becomes y plus 54, that's equal to 101. That's going to give us that x is equal, that's going to give us y is equal to 47, right? Y is equal to 47. So that's the value of y in the second case. So y equals 47. In the third case, x is negative 49. So the green factor becomes y minus 48. And that's equal to negative 1. That's going to give me y equals 47. That's going to give me y equals 47. So y equals 47 here. In the last case, x equals negative 49. So y minus 48, that's the green factor. That's going to be equal to negative 101. That's going to give me y equals negative 53. Right? That's going to give me y equals negative 53. So we have 4 possible pairs of x and y. So those are the 4 pairs. The first one is 53, negative 53. That's the first one. The second one is 53, 47. The third one is negative 49 and 47. And then the last one is 53. It's negative 49 and negative 53. Now, these are the 4 integer pairs, but we're just asking for how many. So in this case, we're going to get an answer of 4. But just in case you guys are interested as to what are the solutions, it's going to be these 4. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye.